Okay, for what we have in section 8.4, we're looking at solving for x and y. And for this system of equations, we're looking for the values of x and y such that y equals x squared plus x minus 16, and also where y is equal to negative x plus 18. Since we're looking at the same y values, okay, we can set the expressions to which we have each of these to be settled or set equal to, and we can rearrange whereupon we can set, think of it like y is equal to y. And so we can set x squared plus x minus 6 is equal to negative x plus 18. So we had the formation of a quadratic equation, and we have the second degree term on the left hand side in this formation. And let's say if I move the terms from the right over, and so we're going to have in the rewrite, we're going to have x squared, x plus x becomes 2x, and negative 6 minus 18 is going to become negative 24. And looking at what we have upon factoring, okay, and it looks like we'll have x plus 6 quantity. We have times the quantity of x minus 4 is equal to 0. And from the zero product property, if x plus 6 is equal to 0, we have x is equal to negative 6. If x minus 4 is equal to 0, okay, so we have that x is equal to 4. And for y, okay, so y is equal to negative x plus 18. So y is equal to the negative of negative 6 plus 18. And the opposite sign of negative 6 is positive 6. And if I add 18, it's going to result that we have 6 plus 18 is going to be at 24. So we have in mapping together, whenever x is at negative 6, we have that y is equal to 24. And in the case of what we have whenever x is equal to 4, we had that y is equal to the negative of 4 plus 18. We had that y is equal to minus 4 plus 18. And from this, negative 4 plus 18 comes out to 14. And so we're going to have here, whenever x is at 4, we have that y is equal to 14. And so just transferring what we have here. Now we're going to have two different order pairs here. Okay, so we have at one end, we have negative 6, 24. And we have also possibly that whenever x is 4, we have that y comes out to 14. And checking out, and the result is correct. For what we have in the second problem, okay, now we have in this particular system, now we have that y plus 5x is equal to negative 6. And simultaneously we have that 4x squared minus 17x minus y is equal to negative 2. And what I can do here is that I can write the first equation in terms of y equals. So we're going to have in this particular rewrite, so if I isolate y, we have that y is equal to negative 5x minus 6 if I just move the 5x over. And I'll just expand the view here. So that y is equal to negative 5x minus 6. And if I substitute into y, and we will have for the rewrite, okay, so we have 4x squared minus 17x, and have minus y. And again, we have minus y, we have negative 5x minus 6. And we have is equal to negative 2. And here we have 4x squared minus 17x, and we have plus 5x. And we have plus 6 is equal to negative 2. And gradually combining, we have negative 17x plus 5x, so this would be a negative 12x. We have plus 6 is equal to negative 2. Here we have a quadratic equation, and if I set this up in standard form, so if I add 2 to both sides, so we have 4x squared minus 12x plus 8 is equal to 0. And let's say that if I divide the equation by the greatest common factor, so if I just divide the equation by 4, it will not do anything to the solutions. And we have in the new dynamic, okay, so we're going to have x squared minus 3x plus 2 is equal to 0. And we have upon reestablishing, okay, so I can factor. So we have, so I have at the one end, have the quantity of x minus 1 times that of x minus 2 is equal to 0. And if x minus 1 is 0, I have the x is equal to 1. If x minus 2 is equal to 0, I have the x is equal to 2. And just taking what we have now, okay, so I have from y plus 5x is equal to negative 6. I have y plus 5 times 1 is equal to negative 6. And whenever x is equal to 2, I can go and reference the first equation. Say we have y plus 5 times 2 is equal to negative 6. And for what we have in following through, okay, so we have whenever x is 1, I had that y plus 5 is equal to negative 6. And taking 5 away from both sides, I have y is equal to negative 11. And whenever x is at 2, we have y plus 10 is equal to negative 6. And taking 10 away from both sides, I have that y is equal to negative 16. Okay, so we have mapping together. So we have an order pair, which will be at 1, negative 11. And the other one, which we'll have at 2 and negative 16. All right, so I have 1, negative 11, 2, negative 16. Okay, and so just keying in what we have here. And checking the result. And the answer is correct. For what we have in the third problem, we have x squared plus 7y squared is equal to 26, and 5x squared minus y squared is equal to 22, and setting up what we have in this arrangement. Okay, so we have with this problem, so you have both x and y are expressed in square terms, and again we have x squared plus 7y squared is equal to 26. And again, we have 5x squared minus y squared is equal to 22. All right. And we have a system of equations. And what we can do is that we can cancel out either the x squared or the y squared and go ahead and solve for, in other words, cancel out one set of terms in one variable and solve for the other. And what I can do here, let's say that if I cancel out the y terms and solve for x. So I make this negative y squared into a negative 7y squared. And we have just in the layout, okay, so I have x squared plus 7y squared is equal to 26. And 7 times 5x squared, we have 35x squared. And we have 7 over negative y squared, so this will be a minus 7y squared. And we have 7 over 22, so this will be a rather big number where we will have at 154. And we have upon adding the equations together, you have x squared plus 35x squared, so this will be 36x squared. 7y squared, negative 7y squared go out. and 26 and 154. Okay, so that will go to 180. And we have with division, we're going to have that x squared is going to be equal to 5. And now for your solutions in x, again, from the square root property of equality, we're going to have x equal to plus or minus, okay, the square root of 5. Okay, now, and I can plug x squared at 5 into either of these two equations. And let's say that if I revert back to what we have for x squared plus 7y squared is equal to 26. Okay, so I already have baked in that x squared is equal to 5. So I can say that for x squared, again, so I have 5 plus 7y squared is equal to 26. And if I take 5 away from 26, I have 7y squared is equal to 21. And we have, with division by 7, we have y squared is equal to 3. And we have, in this case, from the square root property of equality, we had that y is equal to plus or minus the square root of 3. So there are going to be 4 distinct possibilities for x and y. Okay, one is going to be where we have square root of 5, square root of 3, negative square root of 5, square root of 3. Also, we have square root of 5, negative square root of 3, and also where we have negative square root of 5, negative square root of 3. Okay, and so just taking what we have here. Okay, so we have radicals throughout. Okay, so we have the square root of 5, square root of 3. See, we have or. So we have negative square root of 5, square root of 3, and we're still adding in possibilities. Okay, so we have, again, the square root of 5. We have the negative of the square root of 3. And we have, with our fourth possibility, we have the negative of the square root of 5 and the negative of the square root of 3. And checking out, and all the results are correct.